but we were not quite happy with the result because, we couldn't set the value really high, or we just see lights kind of the intensity come together like that. There's a large area that sums up to 1 because our scene only handles color between 0 and 1. That's not very good. It's not much freedom for us to do our stuff. So today's topic is going to be, HDR, high dynamic range lighting, and gamma correction. These are kind of the two things you need to know to be able to output images that doesn't look like they came out from 1980s. Okay. So what is gamma correction? I mean, what is gamma? What does this word mean? So there's a distinction when you do graphics or anything that has anything to deal with color. There's a concept called linear space. There's a concept called gamma space. Linear space is basically what we have been doing all this time. We've assumed that the lights are linear and the operations are also linear. For example, if we add two light intensity of 0.4 together, we expect it's 0.8. Operations are linear. Okay? But the problem is, right before we send out the color value to the screen, to the monitor, there's some kind of gamma function that transforms the color when we import. Okay, so the actual color, name is C prime equals C. So this is a linear color, and this is the actual color you see on screen, right? And there's a problem because the gamma function turns out a good approximation of the gamma function is a C to the power of 2.2. Okay. So why is that significant? Why is that significant? So to understand that, let me just demonstrate on a new shader, demonstrate the effect of gamma correction so you see it yourself, you kind of believe what's going on, what I'm telling you. So okay, so color, let color be monocolor. So uv.x, it'll be black to white, right? Nice transition here. However, you can't really see. So you can see how the transition is not linear. The dark area here kind of doesn't really get lighter until up here. And then it kind of stays in the same color range until when it gets close to this area, then suddenly it gets really, really bright. That is because if we draw this out, so this is very clearly it's a 0 to 1, so it's 0 to 1. But that means you probably should expect some kind of linear transition. Instead, you see some kind of weird fall off. That's because if you take so remember that we're going from 0 to 1, right? So if we take actually 0 to 1, so in linear spaces, this is what we'd expect. It's just a straight line here. But if we take the 2.2 power, you can imagine something happens like when a number is a fractional number, it multiplies by itself, it's going to get lower. It's going to be lower than what it was. So obviously this is going to be, something like this. Right, it's not going to be a linear transition. The way you do that is to apply an extra function. In order for the light intensity to translate linearly onto our screen, what we have to do is, cancel that 2.2. So basically we'll do this, right? And 2.2 can be, a anti-gamma function or something, right? If we do this, then we have preserved the linear space. We've transformed, officially we've transformed to gamma space. Gamma space is in which the numbers that we operate will be the values we're putting here are in anticipation that we'll go through the gamma function. So normally when we talk about gamma space, that means this is the space in which we carry this assumption and we deal with the gamma thing explicitly. So this is after we've done the gamma correction for the linear space. Okay. So how do we do that? Well, kind of already spoiled the solution here. You just kind of multiplied by the reciprocal of power, which gives you the linear linear color again. So just going to be actually, let me show you. Oops. Okay, you can see the transition is much smoother now. There's no like white area that's clumped together, and the transition is smooth. The dark area is a little, it's not as dark as before. You can obviously see there's kind of a linear transition. And typically, what I do is I don't tend to use the power function, especially when you do software rendering or ray tracing. It's kind of expensive. You could just simply do a square root, which gives you a really close result. You can hardly tell there's any difference. So usually I just do square root. So this is the gist of gamma correction. All right, so let's do that really quickly in our shader. Right before the color gets transitioned to Fred color, which we'll assume this is in gamma space already. So what we need to do is to do the square root of it. So before this operation, the colors are all in linear space. When we do addition, multiplication, right, all that can assume that everything is linear. The transformation is linear. Post this point, we transform into gamma space, which is output color. So square root will look really different and really bad. All right, that is because we have carried the assumption that we're dealing in linear space, in linear space at all times. So this is not because of the gamma correction being wrong. This is because the values we've set previous to doing the gamma correction is wrong based on the feedback we get, because that's inherently incorrect. So obviously we can just tune down the indirect lighting, and look, this is much better than what we had before. You can see light kind of have influence in a way bigger range because, if we refer back to the curve, you kind of see this the number in this range are much lower than what it used to be, but now it's in the linear space, so you can kind of see the actual true light fall off here. It looks really good. Okay, so there's still one problem that persists, right? So what happens if we do 10? Sure, we've made sure that it's in linear space, but the problem of our only have the range between 0 and 1 still exists. So that's the next problem we're going to tackle. They usually call this HDR, which is, LDR corresponds to low dynamic range. So that means what we have. So basically a 0 to 1 range. HDR is just 0 to infinity. We can have any number we want. So fundamentally, we cannot possibly do HDR because the monitor only has, on a typical monitor, each color channel is 8-bit, meaning that they only have 255 precision. This is the discrete steps between 0 and 1. This is how many shades of gray that could possibly be. If we used all that precision to represent the 0 to infinity, then we couldn't possibly represent any color at all because there was way too many things to include. So what we do is write our shader and color output in with the assumption that we're in HDR. It would go through a process called tone mapping, which tone map, kind of crunch all our color values in between the range of 0 and 1 again. But you say, what good does that do? Only just back to where we started. Not really. Tone mapping, what it does is there's different interpretations, you could see this, but the one that I want to tell you is you have all kinds of crazy, this is what we do by default, right? So we can't access all kinds of crazy values in between 0 and infinity. Then we suddenly cut off everything that's above 1 back to 1. So we have all these different varieties of color intensity gets clamped to just one value, and everything else is maps linear. But this is not good, right? Obviously. Instead, what tone mapping does, so it's the same relation. It's that the bigger values are mapped to, near the top, sure, but the lower values, as the ratio towards infinity gets lower, it gets mapped to, relatively nicely instead of just a clamp, right? Just to clamp, what we do is kind of map them in such a way that the clamping artifact does not exist, and mapping in such a way that the higher values still show up as higher and the lower values still show up as lower, in contrast to what this does, just a cut off, really harsh cutoff, right? So there's something called Rhine tone mapping, which is good enough for this purpose, right? So say we have some color value that's just a scalar. We're going to apply this function to every component of the color, so don't worry about that. It's in the range of 0 and infinity. But what if we do this, though? Color over 1 plus color. This value is guaranteed to be within a range of 0 to 1, and as the color gets bigger, it gets closer to 1, and as color gets smaller, it gets closer to going to 0, right? So this is basically doing what we ideally want to do here, right? This is a basic tone map. This is not very good. You cannot control the exposure rate, which is the brightness of the final image you're getting. A better function for thing which takes into account is in exposure, I believe, is let me just write it out for you, but actually you can't really see what I just wrote, huh? Okay. Realize that my camera is probably blocking it. So this is what I just wrote. So this is the tone mapping function, the very basic one, that maps the infinity amount of numbers in infinity range back to 1 and 0 while preserving their ordering. So hold on. Of course, so if we draw out as a graph, right? This is 0 to this 1, this is the y value, and x, this is input, which is the raw infinity. So it's going to be looking like something like this. It's never going to approach 1. You can see that the colors in the range that's closer to 0 has you can distinct it. There's a lot of distinction between them, so you can tell which colors are which. But as it gets higher and higher, it starts to get very difficult to differentiate the colors. But it's always approaching 1, so there's always some discrepancy there. You can still see the difference in colors if you output the precision in your frame buffer is high enough. So there's that. So now, let's just change the red to be really bright. Okay. So this is currently this is what we don't like. And remember that we should apply tone mapping before gamma correction, because gamma correction assumes that 0.1. Again, before, if you do gamma correction, then we'll be in the gamma space where the transformations are not guaranteed to be linear. We'll have to do it in linear space where just to guarantee the transformation is linear, just to be safe. Okay. So color. Do this. There you go. Doesn't look like much difference, but you can obviously see that instead of just, let me just show you again. Actually, there's a clever way to do this. Okay, you know what? Next, I'm gonna do is if UV dot, I kind of put the untone map thing on the untone mapped version on the left half of the screen, the tone map version on the right half of the screen, just so we're clear on the effect. If UV.x equals less than 0, so it's placed on the left, you do nothing, and if it's on the right, tone map it. All right, it's gonna look really cool. What? Okay. So there you go. So you can see on the left, it's untone map. On the right, it's tone map. Right. Just give yourself a good look on what the difference is. So you can see, obviously, this is very nice, gradual, and here it's harsh and clamped together. I like this version a lot better. So let's switch to just doing tone mapping. All right, and one more thing is that I still think our ambient light is too bright. Maybe something like this. Okay, maybe something like this. That's good. And one thing is, you kind of feel like it's fake because how your brain perception tells you, wait, where did the ambient light comes from? The environment is completely black. So you can kind of fake it by giving the sky some color. Remember before, by default, we're setting it to 0. Here, I'm just going to say sky. So sky is equal to this. Colors by default is equal to sky. So there you go. That's because in here, instead of colored sky, I'm transferring to sky. Okay. All right, that doesn't look very good. Just up it a little bit. I'm gonna find a value that makes it look good. Can't find any. Well, maybe it's better if it stayed dark. I mean, if it stayed dark. Probably better if it stayed dark, man. Okay. So never mind. I'm just gonna leave it dark. So it looks alright. Still the sky color. Do this. I think that looks pretty good, right? Okay, so why don't we raise all our light colors by 10? Why don't we do that for all the light? Just to test out our HDR. It's working correctly, right? Everything is a lot brighter. And you can still see it doesn't look very ugly because it's tone mapped. And I want them to be spreading in bigger range, so let me just kind of add 3 to auto movement positions. Probably should have a parameter for all these things, but whatever. There you go. So that's the HDR version of our light, which looks a lot better in my opinion. And there you go. That's the end of the video. See you in the next one.